Good morning, guys. Welcome once again to our EDA series. Today's our 11th lecture, and topic is nothing but the shift registers. In the last lecture, we are discussing about the shift left register, and today I am going to clear our idea about the shift right register. Before the starting of the shift right register, I would like to just revise our last lecture as well as the how the shift register are work. In the last lecture we see or understood about the shifting purpose as well as how the registers are shift. We know very well in shifting register our data will be stored in the form of a bit, it is 1 or 0. Electronic physics or the electronic devices only know the 2 bit. One is called as the 0 bit and another one is called as the 1 bit. So the shift register are usually used for the moving purpose. Our data, that means the position of a bit which is stored in the shift register, can be moved from left to right or right to left. It is also called as the shifting right or shifting left of the bit position. Now, today we are going to learn about the shift right register, but we yesterday see the our shifting types are usually used for the arithmetic purpose, like that the multiplication as well as the division. The our shifting register or the type of shifting are used for the arithmetic purpose, like the multiplication or division. When we want our data shifting towards the left side by one bit position, what I say, what I say, when we want to shift our data, when we want to shift our data towards the left side by one bit position, it is equivalent to multiplication by 2. It is the equivalent of the multiplication by 2. That means our data which is shifting by one bit position, the every bit takes the position of the next higher significant. The each and every bit takes the next position for the higher significant bit, for the higher significant bit. Now the understanding for with the help of example, our data containing the value of 0100, our data containing the value of 0100, that means in QA the 0 is present, in QB 1 is present, in QC 0 is present, and QD, that is also 0 is present. That means focus on this one. This one is stored at a QB. This one is stored at a QB. After the shifting of one bit, after the shifting of one bit of left side, after the shifting of data by one bit position of the left side, that means the data which is stored in QD, that means the data which is stored in QD is shifted to QC. QC is shifted to QB and QB is shifted to QA. It is only the data shifting, not the value complete. It is a one bit position. So the register, after the shifting of left side, the data which is stored in a shift register is nothing but the 1000, 1000, and E is equivalent to the multiple of 2, which is equivalent to the multiple of 2. Now similarly, our today's topic, that is shift right register. Our today's topic, that is shift right register. That means we are going to shifting towards the right. That means we are going to shifting towards the right by one beat position. By one beat positions, it is equivalent to nothing but the division of 2. It is equivalent of the division of 2. The one idea is clear. One idea is clear here. When we are going to shifting left by one beat position, the arithmetic multiplication purpose is successfully done. The arithmetic multiplication was purpose of this shift register are done in a left and division is done in a right, shifting right. So when we are going to shift our data by one beat position of the right hand side of data, which is shifting to the right hand side, that means each beat or the every beat which is present in a data which is going to the next lesser significant. Now see the example details. Data is the same, which is considered in a left side. The data which is same in a right side. Look at this side. But just one thing, when we adding the another one a beat towards the right side, that means shifting of data. The data which is present in a QA which is shifting to QB data which is shifting in a QC, and QC data which is shifting to QD. That means focus on that one. This one is shifting at a 0. This one is shifting at a 0 on a right side, not a left side. On a right side, and our data will be 0 0 1 0. Look at this 0 0 1 0, and we obviously see here our position is goes to the next lesser significant. That means it is equivalent to the division of 2, which is equivalent to the division of 2. Now let us go details with the shift of right registers. Now let us go with the details of the shift of right registers. This is a diagram for shift register, which is show the right register, which is shows the right register. Now first we just see these diagram. In that diagram, we use the four flip flop. We use the four flip flop of the D type. Four flip flop of the D type. That means D input of the preceding flip flop are sets to Q. Are sets to Q. That means the rising edge of clock pulse is stored bit and move right side Just look at the diagram. In that diagram, we see these first one flip flop are connected to the second one, this B. This A is connected to this B. This B is connected to this C. This B is connected to this C, and this C is connected to this D. That means our all the four flip flop are connected to each other in this manner. And we see the another one, that is clock pulse, which is connected to all the flip flop. We see our clock pulse is connected to the all the flip flops, and this clock pulse plays the major role. This clock pulse plays the major role in this shifting process, because with the help of this clock pulse, our data can be shifting right side. Now, let us suppose initially all the flip flop are clear. All the flip flop, initially clear, and D input is 1. Therefore the shift resistance, it is nothing but the 0 0 0 0. Look at here, 0 0 0 0. Input is 1. Now look at here, our data goes with this line. That means our data is firstly stored in a Q1. Our data will be stored in a first Q1. Now, when we are going to store the data in this first one, that means QA is 1, and all the data remain same. And what happens with the second clock pulse? In the second clock pulse, with the one is, this one is shifting towards this B. This QA, which is shifting towards the B. That means it is goes this one. Our new data will be stored in a QA, and our these two are remain constant. This one and this one remain constant. And what happens with the next clock pulse? Now at a third clock pulse, the data which is stored in a QB, which is shifting to QC, and QA, which is shifting to QB, and our new data will be entered. That means the data is nothing but the 1 1 1 0. Look at this. This one is shifting here. This one is shifting here. Now in the next one, what happened? This one is shifting to here. This one is shifting here, and new data will be stored. That means at the fourth clock pulse, That means at the fourth clock pulse, the data will be 1 1 1 1. The data will be 1 1 1. Now goes with the zero pulse. Now goes with the zero pulse. What happens at the fifth one? At the fifth one, the data will be zero. The data will be zero. That means this one is zero. This one is zero. This data will be stored here. This data will be stored here. This data will be stored here. That is goes with the just on these truth table. What happened? What happened? Zero was enter here. Zero was enter here. This one shifting one here. This one is here, and this one shifting this right side. This one is shifting the right side. Now the next clock pulse, this is 0 shifting right side, and new data will be enter. The new data will be enter. That is 1 1. Another 2 remain constant. Another remain 1 be constant. Not the constant. Sorry, these are not constant. The data will be moved. For 0, this is 0, this is 0, this 0 shifting is here, this 0 shifting is here. Sorry, it is a 0, and here that is 1. At the last clock pulse, the 0 is converted, sorry, shifting to right side, this 0 shifting right side, this 0 is shifting right side. That means our first and last positions are the same. This is our first and last position are same. Though, so it is the data input is the same like that. In case of data input at the fourth one, it is the same one. It is the same one, and our clock pulse is like that. Our clock pulse is like that. But the just one is here. In that previous verse, we are starting with the QD. In the previous one, we are starting with the QD, but this QD was replaced by Q1, QA here. That means here shifting with, sorry, start with the QA, and another same diagram was here. Another same clock diagram was here for next beat, QB for the next beat, QC for the next beat, and so the QD for the next beat. It is the just of the here, sorry, just one mistake was here. It is for the first clock pulse. Just I just revise one this. In that, what happened for a first clock pulse, first clock pulse and the next one clock pulse, and here for the second clock pulse and is here for the third clock pulse and is here, and for the fourth clock pulse as here. Look like that. Okay guys, it is just my mistake. Okay, so it is all about the shift right or the shift right registers. It is the diagram. This is for the truth table and this is for the clock pulse. It is all about the shifting right register. So guys, I hope these shift registers are understood very well. In that shift register, we are discussing about the shift left in a first video and shift right in a second video. I think our next topic will be digital counters. In that synchronous and asynchronous counter was there. In the next lecture, we are see what is the digital counters, and first one, the synchronous digital counter. So guys, I hope you understood the shift registers, shift right as well as shift left registers. I hope you enjoyed this video, and thank you so much.